All right, so in our last lesson, we looked at compositions, which is just a sequence of two or more transformations taking place. Today, you're going to see those transformations and you're going to be writing the rule. All right, we already had a little bit of practice with this, but you're going to be spending more time on doing just that. Okay, so again, you've got to pay attention and look at the picture and identify which is your first pre-image. And it has to be the triangle that has the normal letters. All right, so what we're going to do is down here, we're going to write our three original pre-image ordered pairs. So we've got A is 0, -2. B is -2, -4. And C is -4, -4. Okay. Try. All right, so now I'm going to write down my prime coordinates, and then I'm going to try to understand what's happening. All right, so here's my prime. This obviously is not an isometry. All right, so one of my coordinates is getting multiplied by something. All right, A prime is still 0, -2. B prime is now -6, -4. And C prime is now -12, -4. All right, so hopefully what you notice so far is that the y coordinate stayed the same, but the x coordinate got multiplied by, looks like 3. It's hard to tell when you're working with the 0, but you can tell that -2 times 3 is -6, and -4 times 3 is -12. So to write my rule, I started with an ordered pair, and the first thing then that happened was we doubled the x and left y alone. All right. Now let's write down our next order pair. So A double prime is 0, 2. B double prime is -3, 4. And then C double prime is -6, 4. All right, now remember, we're not going back to the original. We're starting where we left off. So we have to look at the relationship between these ordered pairs. All right, so looking at the x coordinates, it looks like the x coordinate was divided. Oh, and you know what? Oh, hold on. You guys are probably going, she doesn't know what she's doing. That should be a 3x there. Please change that. Definitely 3x. Because here we're dividing by 2, which means you're multiplying by 1/2. So we're taking 1/2 times the x coordinate. And then the y coordinates are the same number, but they are the opposite of what they were. So that's what we need to show, that it's the opposite of y. All right, this is what our rule is, and that's what you need to come up with. Let's do one more. All right, so again, we're going to write down our coordinates starting with the normal A, B, C. So our A coordinate is 1, 3. B is 0, 9. And C is 3, 6. All right, so let's look at what happened. To go to A prime, we're now sitting at 1, 1. B is 0, 3. And C is 3, 6. All right, so when we're trying to identify the rule, slide this up a little bit. We started with our normal xy. And again, it looks like the x's did not change, so x stayed x. But what happened to the y is we divided by 3. Looks like 9 divided by 3, 6. Did I write that wrong again? I did. Oh my goodness. It's 3, 2. It's early in the morning, folks. Stay with me. But that's also then being divided by 3. All right, so what we're going to do is write that as 1/3 y. If you wrote it as y divided by 3, I would not mark that wrong. All right, now let's go to our double primes. So a double prime is -2, -2. B double prime is 0, -6. And C double prime, let's get it right this time, is -6, -4. All right, hopefully you can tell, all right, that did get larger. And the first picture looks like it did get a little smaller, but it's not, the first one was not a true dilation. And this one looks like it might be. If we look at our points, all right, we're multiplying by -2, multiplying by -2, multiplying by -2. All right, so our x is getting multiplied by -2. And so is our y. 1 times -2, 3 times -2, 2 times -2. All right, so we've got a non-rigid transformation happening first, then a dilation with a scale factor of -2 happening second. All right, but that is the rule. Okay, so time to practice and see how you do with writing these transformations and compositions.